Assalamualaikum guys. Okay, good. For today class, right? I'm sorry because we need to start at 8 o'clock. Because I got some meeting at 9. Okay. For those who have a problem with to slide in, right? Because you are what we call it just registered to my class. So I will try to solve it after the class, right? And you maybe try to slide in after the class. Okay, so without further ado, so let's start our class. Last week we don't have class because I'm quite busy at that time, right? Have some meeting need to attend. Okay, everybody, how are you? Good, right? So need to stay at home, right? Also with all the lecturer from UTM also, Johor Bahru except Police, Terengganu and what is it? Kelantan, right? And Pahang. Okay, so where are we? Right. Okay, now we go to this topic. Right. Some of you have studied this one before. Okay, good. Quite nice. Okay. Can I start the class? Alright. Is it okay? Boleh Kena macam ni group ni. Yeah, Ling, LCT. Okay. You are still there. Alright, good. Okay, so signal conditioning. This one you have learned is before for your electronic subject, right? It's talk about the OM. Okay. There are two parts for signal conditioning, which is part A and part B. So let's look for a little bit, right? Introduction, signal level change. Have you learned this topic before? Ada tak? Or because I got two sections today and also tomorrow, I'm quite confused with, whether I have taught this topic before. Ada tak saya pernah baca topik ni? Belum ya? Belum?
Not yet.
Not yet? Okay, good. Alright. As we know, the instrumentation system, what do we have is, okay, so coming back for the instrumentation system, so what do you have? You have the transducer right now, and then you also have the signal conditioning and analog to digital and also display. Alright, our instrumentation need to have a display. So now, for example, the input now is a temperature, and then the output will be in terms of millivolts. It's too small, right? So you need some signal conditioning to amplify it, right? To be in terms of voltage. This one is the analog voltage, and then it will convert to digital, maybe 101010, and then it will display in the LCD, for example. So the voltage is 3.23, okay, for example. Okay, so now so we will learn about this part, signal conditioning. So some of the signal conditioning, it can convert at the different variable. For example, temperature, you use the transducer, the output will be in terms of resistance, and then it can convert it into voltage, right? And then you can use another signal conditioning to amplify it, for example, right? Okay, so we will learn about this part, the signal conditioning. Okay. Alright. Okay. So it can signal conditioning can be used as a signal level change. Amplifier, that means it's amplified. Attenuation, that means it de-amplified. Alright. make it voltage become smaller. Conversion, that means that I mentioned you before, it can convert from the resistor to voltage, for example. And some of the signal conditioning can be, it can do the linearization. That means from the analog voltage or maybe the data that is not linear, it can convert to linear. But currently we use the software, right, to make it linear. And it can also be used as a filtering, okay, to filter out unwanted noise. Okay, before we go through the what we call it signal conditioning, so let's go through a very basic circuit. We call it a Thevenin circuit. All right, what this Thevenin circuit do is, okay, give me time. All right, what this Thevenin circuit do is, you have the complex circuit. For example, let's say this is your circuit. Okay, so you got it is V in. All right, so this one is R1, and this one is R3, and this one is R2. This is the point that you want to measure, okay? And then the Thevenin circuit, right? Using the Thevenin theorem, you can simplify this complex circuit. Let's say this one is the complex circuit. You can simplify it, right? And then you just can have a new a two component, right? So you just need what we call it voltage Thevenin VTH, and also resistance Thevenins. And you also measure at the point A and B. So this point A and B is the same thing. Okay. So how to find the VTH is normally that the voltage at here, alright, A and B here is parallel. So that means the VTH is equal to V R2. That means the voltage divider R2 R1 plus R2, and then you time with V in. Okay. Now you got it a sum VTH here. Okay. This is the formula. For the RTH, how to find that? You just shorted this supply voltage, right? Shorted here. So now you can see that R1 and R2 is parallel. So we can find for RTH, RTH is here. RTH is equal to R1, which is parallel with R2. And then after a parallel, it can become a series. So this one plus R3, R3. So you got it here is 1 over R1 plus 1 over R2 and plus R3. Now you got it is RTH. Okay. So when you calculate the VTH and also the RTH, for example, let's say the VTH is 2 volt and RTH is 1 kilo ohm. Okay, so when you go to any electronic shop, you just buy these two components, right? Supply voltage is 2 volt, right? And also the resistor 1 kilo ohm. You will got it the same output, right? With the complex circuit here. Okay, so that's what we use the Thevenin theorem, all right, to simplify this complex circuit, right, to be just two components, right? Voltage divider and voltage Thevenin and also resistance Thevenin. Okay, so far so good, clear? Is it clear? Right? Okay, doctor, yep. What is it? R2, R2, R2 and R3 is parallel. Parallel. What do you mean is parallel? R1 and R2, when you short it, right? When you short it, Okay. So that's mean when you short it, right? So this one, it will become R1. So R1 and R2 is parallel, right? So when you simplify it, you will get it is this one, another resistor. So this one is R1 parallel with R2, and then you pass with R3. Okay. Do I answer your question? LCT, the brain still loading. Oh, okay, good. Boleh Right. Okay. Short circuit first. Yep, good. Short circuit first. Okay, now next is what else? Okay, right. This is happening. Okay, concept of loading. All right. Let's say you have the transducer and it's connected to the signal conditioning. Okay, so when the transducer, right, connected to the signal conditioning, it will have what we call it loading. Okay, so I try to adjust my camera. Okay, wait, guys, try to adjust my camera. Okay, so now when you have the signal condition, you have the transducer. So actually your transducer, right? Let's say I try this one. Okay, this is your transducer. So your transducer, first, let's say is detect the degree. Okay, so what happened? It will generate some voltage here. Let's say the millivolt. Right? Okay. So actually, this internal transducer, right? What happened is okay. Now your transducer now is like this one. I call it Vx, and this one the Rf. So transducer have the internal resistance, right? Internal resistance. We call it internal resistance. Okay, and then your transducer, the output will be millivolt, right? It's from the Vx here, right? Okay, actually this one, the output will be at point this one and point this one lah. Let's say this one ground. Okay, so this is the output here, right? So there will be some voltage drop here. Okay, right? Up. Okay, so right now when you connected to the signal conditioning, right? So this is your signal conditioning. So your signal conditioning will have some, we call it load here. Okay, this one we call it load, right? In the signal conditioning, and then this signal conditioning will have some output V out. Okay, this one V out. Let's say this signal conditioning had a gain, for example, time by 10. Okay, and then the what we call it the load resistance, right? We call it RL. Okay, this one we call it loading, right? This one the loading, right? So there are two types. When you ignore the loading, right, that means the resistance at here is equal to 0, right? equal to 0, almost equal to 0. Like you can make it a short circuit, right? So from here, you can get it is V out equal to, uh, hmm, let's say we say that, okay, this one is the V in, this one V in, okay. So V in equal to Vx, right? V in is the voltage input for this signal conditioning, alright? Okay, so now you can get it, Vx is gain time with V in, time with V in, okay? So this one, we when you ignore the loading, right? So maybe your amplifier, right, is very ideal, very good. That means the resistance load equal to 0. Now, when you don't ignore the loading, that means the loading is included, right? So this one is RL. Okay. So the equation will be difference. So V in equal to, okay, V in is equal to RL divided with Rx plus RL time with your Vx. Okay. What is it? Why I got it? Okay. Hanging. Nope. I can't see any request. Nope. Nope. Okay. Right. So this V in will be RL over Rx plus RL. So this slide is quite different with your slide. Okay. Alright. Time with Vx here. So what you can see here is there will be a voltage drop happen, right? Okay. Okay. Alright. So now we sorry, this guy, sorry. So this one V out. So now is V out is equal to 10 V in. Okay. So V out here is equal to 10, you time with V in here. Okay. So let's say Vx here is 2 volt. Okay. 2 volt. So now you will got it is 2 volt, right? Is to be in. Okay. And when you have include the loading, so now your V in is not 2 volt anymore, right? Because it will drop here. So you will got it as like 1.5 volt. Okay. So the output is just 10 you time with 1.5 volt. Okay. Alright. Any question? Ada apa-apa soalan? Any question that you want to ask? Doctor at whiteboard got reflection. Ha ha ha. Okay. Sorry. Right. That's why the UTM need to prepare a good whiteboard maybe. Okay. Gain is always time 10. No, it depends your OM. So after that we will learn how can we adjust this gain. This is the example. Okay. Alright. So let's move to the next slide. Okay. Example 5.1. Okay, before that, let me show you this one. This one is quite different with your slide. I'm not updated yet the slide in the e-learning. Okay, but I want you to know the concept of loading. Okay, alright. Example 5.1. A sensor output has a transfer function of 20 millivolt per degree. The sensor has the internal resistance of 5 kilo ohm. The sensor is connected to an amplifier output. To an amplifier output that has gain equal to 10. Okay, the amplifier has the input resistance of 10 kilo ohm. If the temperature is 50 degree, find the amplifier output when loading is ignored. Okay, so in this case, Alright. So let's we gather the information from the question first. Okay, example 5.1. Now you have sensor output. Okay, so this is your sensor output. So the sensor transfer function is have 20 millivolt over degree. That means the output now is millivolt. The input now is degree. Now it have the internal resistance 5 kilo ohm. So this is your uh, internal resistance of your sensor. Okay. Then as else, and then it connected to the amplifier that has gain. Okay. Now it's connected to the amplifier. Okay. And it has gain 10. And then it has the we call it the resistance is 10 kilo ohm here. So this is your V out and this is your V in. Okay, so this is the information that we got it from the question, and it says that the input now is 50 degree. So 50 degree you can time with 20 millivolt. 50 degree time with 20 millivolt over degree. So now we got it is what? 1 volt? Is it? Okay, 1 volt. Okay. So you got it is 1 volt here. So that's mean for input 50 degree right to the transducer right now. So you we got it is 1 volt. Okay. Right. Okay. So find the amplifier output. So our objective is we want to find the V out. So we know that V out is 10 times with V in. Okay. So how to find the V in when the loading is ignored? So type A, loading ignore. Okay. So that means you don't have the loading here, right? So that means you short the circuit. So V in here is equal to Vx here. Vx is equal to 1 volt. So that means this one 1 volt. Okay. So V in here equal to 1 volt here. Okay. 50 degree, it will produce 1 volt, right, from the transducer. So this one, the transducer, Alright. Transducer. So this one, the signal conditioning. Okay. Right. So this one, when loading ignore, so you got it, V in here is equal to 1 volt, or V in equal to Vx here. Okay. So then you can got it, V out is 10, you time with 1 volt. So now you got it 10 volt here. Okay. Done. Oh, got reflection. Okay. Alright. Okay. And when you include the loading, alright, loading you include, that means you will have some resistor here, resistor loading RL. Okay. So now we can get it is V in RL divided RL is your RL now is 10K. 10K. So that means 10K divided with a potato divider 5K plus 10K you time with 1 volt here. Now you will got it is what is it? 0.67 volt, and then you can get a V out 10 times 0.67. Now you got it 6.67. 6.7 volt. Okay. Alright. Okay. So that's it. So when you ignore the loading, right? That means loading not include. So this one will be short circuit. So V in here will equal to the output voltage from transducer. Okay. This is the circuit, right? So when you connected the transducer with the signal conditioning. So this one is the internal circuit. Okay. Any question? Ada apa-apa soalan? Do you have any question? Is it clear? Doctor, does input resistance will always be the load? Muhammad Zami, so do you mean the this one 10K? Yes, yep. Yep, it is always be the load, right? Okay. Sometimes we call it this one is the input impedance lah. Okay. Okay. So next we move for the amplifier. Before that, you can see that before this is 10 volt, right? And when you ignore the loading and when you include the loading, so the output will become 6.6 volt, right? So of course, when you have the loading, that means it will we call it voltage we drop a little bit. Okay. Okay, so let's move to amplifier. So amplifier is used to amplify and also attenuation di amplify. Okay, this one is the theoretical soal. Okay, I don't want to go through. Okay, the very basic amplifier we use the OM741. So it have only one output. Okay, so on what you have done in the lab one, right? In your second year, right? In electrical lab, so you use that one is LM324, right? That have I think four output, right? Four output or two output, I don't remember time. So um, so let's look the OM can be configure a lot of things. So one of the example is inverting amplifier. So what this inverting means, that means when the voltage input from here, right, it will amplify or attenuate or de amplify, all right, and then but the voltage will be invert. That means, for example, the positive voltage, the input, right, the output will be negative voltage. So that's why we call it invert. Okay, right. So this one, the equation here, right? Okay, so let's look. Okay, so first is inverting, right? So how to draw the circuit inverting is quite simple. Now this is the signal conditioning. It start from minus and plus, and then plus we always go to ground for the inverting circuit, and then it have the feedback resistor. This one we call it feedback resistor. Let's say this one the R2, symbol is R2, and then you got it is R1 for V in. Okay, so the input resistor here, right? We call it is input impedance. Okay, right. So now you got it is V out here. So based on the derivation that show on the slide, right? You do and so on. So you we got it. The output is V out is equal to minus R2 divided with R1 you time with V in. Okay. So where is your gain? We can say, right, you can take also negative R2 over R1. Okay, but actually the gain it actually is a positive, right? Because you only have the gain time with for example 10, or maybe the gain is time with 0.1. Okay, so the symbol negative here, that means it will invert it. Okay, so let's say the V in, now you got it 0.5 volt, right? So when you have the gain 10, that means the output will be 5 volt. Okay, now for example you have the V in is 5 volt, so 5 volt when you time with 0.1, that means you got it 0.5 volt. Okay, so this one, when the biggest voltage becomes smaller, so we call it is attenuation or de-amplify. So your gain, you can adjust it between R2 and R1. You have learned this one in Lab 1, right? In your second years. Betul kan? Dah belajar kan? You have learned this one before kan? Dah kan? Alright. So, you just adjust the R2 and R1 to adjust the gain. Right? So that's why we call it, yep, it's inverted. Okay. This one for the inverting configuration. Okay. All right. For non-inverting amplifier, right? So is all the inverting is from the for others configuration, right? Is only from the inverting. Okay. Let's say we want to draw the non-inverting circuit, NON inverting. Okay, so first of all, you just draw the inverting circuit first. Alright, it have the triangle here and feedback resistor. Okay, so this one R1, R2, and this one V out, and also V in. Okay, so now in order to draw the non-inverting, you just switch this ground and V in here. You just switch it, alright? So delete here and delete here. And this one is shorted to ground, and your this one is V in here. Okay. Now this is become the non-inverting, right? So all is based from the inverting. But in order to draw the non-inverting, you just switch here. Okay. Then the formula will be V out equal to 1 plus R2 divided with R1. You time it with the V in. Now the gain is 1 plus R2 divided with R1. Okay, that's it. Right. So you can adjust any gain that you want. For example, you want to adjust 10 times by 10. So that means your R2 need to be 9K and 1K. So that 9K divided with 1K, you got it 9. Okay. So 9 plus 1, so you got it 10. Okay. Alright. However, for non-inverting, you cannot multiply with 0.1, right? Because of this one. Right. So this one is already you learn in your lab 2, right? Labs number 1. Okay. Okay, so let's go for example 5.2 here. Alright, before that, so if you have the resistance, right, like here, right? So this one we call it input impedance. And for the inverting, this one we call it is the input impedance. Okay. And to make this inverting, right, to make the same positive, right? Because the input is positive, you want to get the output is positive, you need to another inverting amplifier. We will look into that. Okay. Alright. Okay. Example 5.2. good job. Right. Okay. Okay, so example 5.2 here. Show how OM can be used to provide an amplifier of gain plus 100 and the input impedance of 1.5 kilo ohm. Show how this can be done using both inverting. Okay, so right now we want to do the inverting first. Okay, inverting, that's mean you just need triangle here, minus, minus plus going to ground, and then you have feedback resistor here, and then you got it the input. Okay, so this one be in, this one R2, this one R1. Okay, now you got it. Now is you got it be out here. Okay, right. So it says that the input impedance is 1.5. So for inverting circuit, this is the input impedance R1. Okay, right? And we want to get to achieve plus 100. So that means this one, when you calculate the gain, right, it become negative R2 over R1. Okay, so we can find the value of R2 first. So gain 100 minus R2 divided with 1.5. Okay, that means R2 now you can got it is 100. Okay, okay, minus R2 is 100. Okay, okay, so sorry, 100. Okay, okay. So now when you got it 150k, okay. So this one the output will be negative. Okay. So now you can got it is gain here. We can say gain here is minus 100. Okay. All right. So this one you can bring here, and then you want is positive 100. That means you need another amplifier minus and plus going to ground. Okay, right. So this one you can use any resistor, but it need to be have the same value. For example, I choose 1k and 1k. So right now gain here for this one, I got it minus 1. So overall gain minus 100 times with minus 1, we got it, we call it overall gain, we got it 100, okay, plus 100. Okay, so this is your output, V out. Okay, so V out here, we can say it negative V out lah. Okay, so inverting, when you have two inverting here that you combine it together, you can achieve plus 100. Okay, that means the uh, positive gain. Okay, alright. Okay, any question? Ada apa-apa soalan pasal ni? Ada apa-apa soalan? You can look at the solution here. Any question? No? Ada apa-apa soalan pasal ni? We want to achieve plus 100. That means we need to inverting. Right? Okay. But the second inverting, you need to choose same value. Okay. Now, let's do the non-inverting. Non-inverting. So, in order to draw the circuit for non-inverting, all is based from inverting. Okay, all the circuit is from inverting. So this one you got it R2, this one you got R1. Okay, and then this one they'll be in, and this one they'll be out. Alright, so for the non-inverting, that means you just switch this one and you put it switch between ground and V in. So this one your V in. Okay, and then the input impedance for this non-inverting is here 1.5k. Okay, so this one will be up. All right. Okay, so at this point, right, is also equal to V in here, because V in here is parallel. Okay, let's say I draw like this one lah. Okay, to make you clear, plus minus. So this one V in here and V in here and voltage at 1.5k is parallel. Okay, so now you want to get it the gain plus 100. Okay, gain 100 plus 100, that means 1 plus R2 divided with R1. So let's say we choose the R2 is 99k and R1 we choose is 1k. So 99 divided with 1k, so you got it 99 plus 1, then you got it 100. So when you draw a circle, that means is 99k and then this one 1k. Okay, now when you use the non-inverting, yes, you can get it plus 100 positive. Okay, alright, is it clear? Ada apa-apa soalan? Do you have any question? Okay, so which one is simple in order to develop the circuit? That means this one you need 2 ohm, 2 741 ohm, and this one you just need only 1 ohm. So what so what we say this disadvantage of this non-inverting is only can be used to amplify. All right. Okay. All right. Any question? For R1 and R2, we can choose any value for non-inverting. Yes, you can choose any value. For the input impedance, right? For the non-inverting, this is the input impedance. For the inverting, this is the input impedance. Okay. Alright. Do you have any question? Ada apa-apa soalan? Ada apa soalan? Tak ada. Do you have any question, guys? Okay, no question. So that's it for our class for today. Bye bye. I got a meeting after this. Right. So you can continue to what we call it to continue with your dream. Okay. Yeah. Sleep. Good. Sleep. Okay. Good. Duduk rumah buat apa lagi? Tidurlah. Alright. So I will see you again next week, insyaAllah. Assalamualaikum and good morning.